here. I'll send these around as well. The others were imperfect in that what was formed was a little too fragile, and so they ended up breaking on me. So I thought I'd bring some that weren't broken yet. But I'll send this one around. It's a little wet, but you'll notice a very thin plastic casing here, and if you touch it, you'll probably break it. So don't touch it too hard. But so the idea here is that these pop cans, which are made out of aluminum, are not completely made out of aluminum. They have a thin plastic liner on the inside of them. And so what I have done is to take some copper chloride and put it into solution. And before putting the can into that solution, I scraped away at the paint coating on the aluminum surface. You'll notice some of those cans that are going around that are the dry ones are sort of chewed up on the bottom a little bit because the bottom is not painted and copper chloride started chewing away at the aluminum there. For the one that I just sent off that way and that I'll send off over this way, oops, there I did it. I broke the little plastic coating there. Here we go. That's a wet one. So by putting some copper chloride into these containers, it's reacting with the aluminum, doing a redox reaction. The aluminum is going to aluminum 3 plus, and then the copper is going, copper 2 plus is going to copper metal. And one situation that I have here where that's the case, I just chewed up the bottom of this. I took a little small layer off. That's still pretty much just aluminum there. But you'll notice a reddish liquid in here, which is due to the metallic copper. And in this one, I just have some copper, but it's not copper chloride, it is copper sulfate. And so if I take some copper sulfate, add some water to it, dissolve it a little bit, the question is whether or not that will react with the aluminum surface on this container. And I should see it go immediately. If that's the case, it doesn't seem to be reacting to any extent. And the reason for that, or at least as near as I can tell, is that copper sulfate does not do a particularly good job at eating away at the aluminum oxide layer that's created as soon as you scratch off that paint coating. And so once that paint coating is gone, you've got a surface of aluminum oxide. Copper sulfate can't get to it, but the copper chloride can, because chloride is a pretty good etching agent for the aluminum oxide. So to see if that's actually the case, we can add a little bit of sodium chloride to our solution, mix that up, we'll put this back in, and immediately we should see the reaction go. And I'm seeing some bubbles already being given off here, and the surface is turning more of a rusty color. So that's the see-through pop can. So if I let this go long enough, I should be able to etch away at this side, and then I've actually etched away at the side over here as well. So I should be able to see straight through the pop can with those 2 plastic layers being the only thing keeping the light from going through. The other thing that you can do with this, and you may have seen it before, is to etch the inside of the can, right, where you scrape away at the plastic layer from inside, and then add copper chloride to the inside of the can. And what will happen is it'll etch away at the aluminum surface on the inside, leaving behind just the paint layer. And so then you challenge 2 kids to come up and ask them to pull a pop can apart, right? And you give the football player the full can, right? And you give the cheerleader the can that has nothing in it, and she's gonna pull it apart immediately. The football player is gonna be over there going, I don't know why I can't pull this one apart. So that's the other take on it. I didn't have particularly good luck in scraping away at that that plastic liner, but I understand it's not terribly difficult to do. But I didn't have luck. One time I tried it. So that's my see-through pipeline.
Paul,
Yes.
have you ever tried it with the pop in the can?
Which aspect?
Just put the whole thing in, dissolving it, then you can see the pop in the can without.
Oh, I have not tried that. You should be able to do it.
That's why I'm
It's
asking.
going to make a mess. The plastic.
I want to see it. I'd like to see that. That would be interesting.
It would be. Yes.
How do you take the inside plastic layer off?
So one way that they said to do is just take a file or something like that and just bring it around the edge.
Triangular file, where inside, I think triangular file is straight.
I tried that, but it didn't work for me. I don't know why.
Maybe it's a screwdriver.